Right. Now we write the formula for the inductance, and defaultly you need to consider that. So in this question they ask about the inductance per phase per kilometer. Now here you have to consider the system is fully transposed on the distances are unsymmetrical. Okay, why? Because A and B have the 6.5 meter, B and C have the 6.5 meter. Now A and C are the different, so therefore the spacing between the phases are the unsymmetrical and it is a transposed. So what is the formula for the transposed inductance? So it is the inductance for three phase unsymmetrically transposed. The formula is L inductance equal to 2 into 10 to the power of minus 7 ln of GMD by GMR. Okay, so GMD by GMR. Here this is the Henry per meter. So this formula is for Henry per meter, but in the question they asked for the inductance per kilometer. Therefore we write this equation as the 0.2 ln of GMD by GMR milli Henry per kilometer. Then this is the formula for our question, 0.2 ln GMD by GMR milli Henry per kilometer. So in the question they given the two conductor bundle. Therefore we have to consider mutual GMD. Therefore mutual GMD is what? So it is the 3th root of DAB DBC DCA. Actually this is the formula for the GMD for the three phase, 3th root of DAB DBC DCA, 3th root of DAB DBC DCA, or you can write like this also, DAB DBC DCA whole power 1 by 3. So this is the formula for the GMD. But in the actual case we can write like, so DAB equal to, because it is a two conductor bundle, right? DAB can written as the 4th root. So 4th root of DAB DAB dash DA dash B DA dash B dash. You can take this formula also if you want to do the accurate one, but the calculation after these using formulas DAB and DBC DCA and substituting this into this formula, it gives the same value. So that is the reason here we are calculating directly. In the question also they given from center of the phase conductor A to conductor B, they given 6.5. that is the scenario. We take the directly A to B is the 6.5. Therefore the distance we can directly substitute that distance between DAB is, what is the distance? 6.5 meter. Distance between the DBC is 6.5 meter. Distance between the DCA is 6.5 plus 6.5, which is 30 meter. So directly we substitute in the GMD equal to 3th root 6.5 into 6.5 into 13. Now we should calculate this by using the calculator. So shift root. So this is the 3th root. Now I am substituting the value 6.3 into, sorry, what they given, 6.5 into 6.5 into 13. So it is 8.18. So the distance GMD is 8.189. So 8.189 approximately I am taking 8.189. 19 meter. So listen carefully. The units are must and should important. The given distance are in the meters, so definitely we should calculate in the meters. Now we got the GMD. Now we need to find the GMR. So GMR for this bundle conductor is something different. Actually GMR, what we write the formula? So GMR equal to, for a single conductor, GMR equal to R dash, nothing but GMR is called as the R dash. R dash equal to, we write it as the 0.7788 into R. R is the radius of the conductor. But in this scenario we write GMR is nothing but mutual GMR. This can be also known as the mutual GMR. We can call it as the self GMD. We can call it as the self GMD DS. Okay, which is equal to 3th root of D SA D SB D SC. 3th root of DSA DSB DSC. Okay, now what is the DSA? DSA equal to 4th root DA D A dash D A dash A D A dash A dash. So this is the formula for DSA, and similarly for DSB and DSC. Here the note point is where DAA equal to DA dash A dash equal to R dash. DAA DA dash A dash equal to R dash. It's nothing but we have to substitute in the DAA and DA dash A dash. We need to substitute this value, which is 0.7788 R. Okay, similarly which is equal to the, so this is for RA dash, and the next we can write, because we are taking the conductor ABC, so this is regarding the conductor A. I am keeping this RA dash. Now for the DSB, it is also a 4th root DBB DB dash DB dash B DB dash B dash. Okay, and similarly for DSC, so 4th root DCC DCC dash DC dash C DC dash C dash. Now, so in all these we written that in the question what they given, the conductor diameter is 4.5. so they given conductor diameter equal to 4.5 centimeter. Remember they given in centimeter, which can be write diameter in the meter can be write as the 4.5 into 10 to the power of minus 2 meter, because I am converting centimeter to meter. Now we want the radius. Radius equal to diameter by 2, which is equal to 4.5 into 10 to the power of minus 2 by 2. Now substitute this value. .5 into 10 to the power of minus 2 by 4.5 into 10 to the power of minus 2 by 2, which is equal to 0.0225 0.0225 meters. Now it is the meters because we convert it into the right. This is equal to R. Therefore R dash equal to 0.7788 into 0.0225 equal to 0.0225 into 0.7788, which is R dash equal to 0.017523. So this is the R dash in the meters. Okay, in the question they given the distance between the A and A dash and A dash to A, and B to B dash, B dash to B, C to C dash, C dash to C. Okay, the self GMD, which is the A dash, A dash, B B dash, B dash, C C dash, C dash. Okay, I hope you got the clarity. Okay, now we substitute in the DSA, which is fourth root. What is the DAA? DAA is nothing but equal to RA dash, which is nothing but this one. RA dash anna R dash anna rendu okate. So kabatti 0.017523. Okay, into distance between distance between A to A dash. Distance between A to A dash is 40 centimeter. సో 40 సెంటీమీటర్ కాబట్టి ఇచ్చింది సెంటీమీటర్స్లో కాబట్టి దీన్ని మీటర్లోకి మార్స్తే 40 ఇంటూ 10⁻⁻2. అండ్ సిమిలర్గా ఏ డాష్ టు ఏ కూడా అదే డిస్టెన్సే కాబట్టి 40 ఇంటూ 10⁻⁻2 ఇంటూ మళ్ళీ సేమ్ ఏ డాష్ అంటే 0.017523. 0.017523. Now we calculate this one. Okay, so we should calculate in the fourth root. So shift root, we should take here the fourth root, 0.017523 into 40 into 10⁻⁻2, 40 into 10⁻⁻2 into 0.017523. So the calculated is 0.0837. So DSA equal to 0.0837 meters. Okay, so ఇక్కడ ఇచ్చిన కండక్టర్స్ అన్నీ సేమ్ డయామీటరు సేమ్ డిస్టెన్స్ కాబట్టి I can write DSA equal to DSB equal to DSC equal to 0.0837 meters. ఇప్పుడు దీన్ని తీసుకెళ్ళి జిఎంఆర్లో సబ్స్టిట్యూట్ చేస్తే మ్యూచువల్లో 3th రూట్ DSA DSB DSC దట్ ఈక్వల్ టు 3th రూట్ 0.0837 into 0.0837 into 0.0837. ఇదేంటి క్యూబ్ రూట్ కాబట్టి ఇవి 3 ఉన్నాయి కాబట్టి క్యూబ్ క్యాన్సిల్ అయిపోయి ఇంకా మనకి ఏం మిగులుతుంది, సేమ్ ఆన్సర్ వస్తుంది 0.0837 వస్తుంది. కావాలంటే చూడండి 0.0837 ఇంటూ 0.0837 ఇంటూ 0.0837. సో సేమ్ ఆన్సర్ వచ్చింది కదా. సో 0.0837 meters. This is the GMR. Now we have the formula for the values for this inductance. Inductance ఏంటి? L inductance per kilometer per phase. ఇంకో విషయం చెప్తున్నాను, మనకి డైరెక్ట్గా మన ఫార్ములా డిరైవ్ చేస్తున్నది ఇండక్టెన్స్ పర్ ఫేసే కాబట్టి క్వశ్చన్లో పర్ ఫేస్ అడిగాడని మనం కంగారు పడాల్సిన అవసరం లేదు. మనం ఫైండ్ అవుట్ చేస్తున్న ఫార్ములా డైరెక్ట్ పర్ ఫేజ్ వాల్యూనే. ఓకే, బట్ పర్ కిలోమీటర్ కావాలంటే ఇది తీసుకోవాలి. ఓకే, సో పర్ కిలోమీటర్, నౌ వీఆర్ టేకింగ్ ది పర్ కిలోమీటర్. ద ఫార్ములా ఈజ్ 0.2 ln GMD by GMR. Simply substitute the values. L per kilometer per phase equal to 0.2 ln of GMD. What we call GMD here? 8.19 in meters only. 8.19 by what is the GMR? 0.0837. 0.0837. Okay, so remember the answer directly will come in the millihenry per kilometer. Okay, the answer will come directly in the millihenry per kilometer. 0.2 into ln. నా క్యాల్సి ఇది మొత్తం ఎరేజ్ అయిపోయింది. ln ఎక్కడ ఉంది వెతకాలి కొంచెం. Right. So this is the ln of 0.2 into ln of GMD 8.19 by 0.0837. Okay. So inductance L inductance per kilometer per phase equal to, so ఎంత వచ్చింది ఆన్సర్ 0.91668 0.9166 ఉంది కాబట్టి నేను 0.917 మిల్లీ హెన్రీ పర్ కిలోమీటర్. దిస్ ఈస్ ది inductance per phase. Okay. Next we find the capacitance.